Course. Good. Anyone else who wants to basically give their point of view, their past understanding about momentum? What do they know about momentum? Let's say if I ask anyone, let's say a layman, right? A common person about momentum. How would you define momentum in simple terms? Whatever you know. Hamza was close. Anyone else? Okay. ठीक है. So let me give you an example before starting, right? Imagine let's say if you're going, let's say on a cycle, right? Let's say you're bicycling, right? Let me just draw the bicycle. This is your bicycle, let's say. Okay, and this is the seat over here, and this is your handle, right? So let's say this is person named Ali, right? Ali is going on a road, right? He's driving his, he's cycling his basically bicycle, and it's a sunny, bright day, right? And he loves to cycle. So imagine now, let's say there is a bee, right? A small bee. Have you ever faced, let's say, ever you are bicycling, or let's say if you are going on a road, have you been basically have you basically contacted or let's say made a contact with the bee? किसी का हुआ है कि bee आके it hit on your forehead or any part of your face whenever you're bicycling or going on a car or let's say going on a bike. ठीक है? Raise your hand who has encountered this scenario. Okay, Masha has encountered this scenario. And also, right? So imagine you, okay, so what is the, let's take this, right? The mass of a bee would be around, let's say, 0.01 kg, right? It's pretty small. And your mass of Ali is, let's say, 60 kg, right? So imagine this, that's such a small mass when it hits your forehead or any part of your face, right? You feel so much pain, right? So Masha, can you explain your experience? What happened and how was your basically reaction, right? Can you define your experience in some, yeah.
I don't remember actually, but when I was riding bicycle in early morning, and a bee out of nowhere came and it just hit my forehead. And I felt like something has been hit on my forehead, but I didn't quite know what it was. So it felt a little bit pain there was there, and just let
Okay, good. What about Ryan? How was your experience? I have experienced this myself also, right? Just a small beam and it hits your forehead or your face. It basically strikes pretty sharply on your forehead. Okay? And you just imagine it, it has such a small mass. How can it strike and how can it cause such a huge impact on your forehead, right? Ryan, how was the experience?
So yeah, it was like that.
Okay, yeah. Okay, so because what is happening, right? Because it is the bee was moving with the velocity also, right? It was moving, let's say, with a velocity of 50 meter per second. That's a huge velocity, right? So we're gonna relate mass and velocity into a quantity, right? So it will make sense now. Okay, why did it pinch you in your face, right? When it strike your forehead or any part of your face. So that basically phenomena will be explained using momentum, right? Up starting formally. What is momentum? So momentum is as follows, right? So momentum is used. Let me just skim the content and then we will do example, right? So momentum is a useful quantity, right? It's pretty useful. So when bodies are basically colliding or exploding, right? So in this particular example, the B is colliding with the face of Ali, right? So there is a collision, right? There is a collision. So this basically includes basically this introduces the phenomenon of momentum. So what is momentum? It is pretty simple. It is defined as the mass of the body multiplied by with the velocity, right? Right. So this is the formula of momentum, and this symbol is called. This is a foreign symbol, right? This is a Greek symbol. It's a Greek symbol, right? Which is basically called rho. Okay, and m is over here. What m is your mass, right? Mass is in kg, and v is your velocity. Okay, that is your velocity. that is in meter per second, right? So, and this is the following formula, right? If you have a question in your theory exam, let's say it says, okay, let's say what is momentum, right? So you can simply use this definition in your blue box to answer it, right? Momentum is basically mass times velocity. That's it. That is your definition of momentum. And how do you define this formally? Okay, using a formula that is as follows, right? Let's see how do we have this, right? How do we have this SI unit, right? What is an SI unit of a quantity? Can you even explain what is meant by SI unit? What is meant by SI unit of a quantity? We had done this in the first chapter, right? We defined SI units definition. What is it? Can you
So
explain?
SI unit is a standard unit given to every quantity. For example, for mass we have kg, and
Mhm.
for
Good.
speed we have meters, and like that.
Good. So SI stands for System de International Unit System, right? It stands for System de International System de International Unit System, right? So it basically defines some units of the quantities which are standard throughout the entire world, right? Like mass is measured in kilograms throughout the world, velocity is measured in meter per second throughout the world, right? So let's find out the SI unit, right? What is the SI unit of this quantity momentum, right? Let's find out the SI unit. Let's find the SI unit of momentum. So what is the formula of momentum? Can anyone tell me the formula? Rho equals to what?
Mass multiplied by velocity.
Right? Mass time velocity. And let me just write down the terms. M stands for mass, right? M is mass that is measured in kilograms. And your V is your velocity. If anyone has a question, please raise your hand and ask, right? Don't stay quiet or don't feel shy. Ke it is a stupid question. No question is stupid, right? Okay. So if you have a question, ask. So let's find out the SI unit of momentum over here. So M is mass, so kilogram comes over here, and velocity is meter per second. So we have one representation of the unit of density. Oh, sorry, not density, momentum. That is kilogram meter per second, right? Okay. Now, if you recall, now let me just shape it into another form. Okay. So momentum has a base unit of the SI unit of kilogram meter per second. But if you recall your theory, it is also measured in Newton second, right? It is also measured in Newton second. तो अब ये कैसे आया? Let's check it out. If you recall your force का formula, what is force का formula from Newton's second law? That F is equals to ma, right? And what if I basically replace this? So what is basically the meaning of ma? M is kilogram and acceleration is meter per second square, right? So this is corresponding to Newton. So we have learned this in chapter of forces. How do we define, how do we identify, how do we derive the unit of force, right? So how can I shape this formula into this form? How can I shape this formula? Let me reiterate my point. I'm asking, okay, how can I shape this formula into this form? What change do I need to do to get into this particular format? If I do this, if I multiply and divide with second, so kilogram meter per second, multiply and divide by second, right? So what is second upon second? It is one, right? So it doesn't change this basic formula, right? But it gives me something interesting. That is as follows. That density equals to kilogram meter per second square into second, right? So what is this particular thing? It is, it is what? It's Newton, right? So therefore, I can also write down the SI unit of momentum as Newton second, right? So we usually use this particular SI unit for the momentum, and that's how you derive it. If it is clear, give me a thumbs up, please. If this derivation is clear, give me a thumbs up. It is clear to Mashal, Ryan. What about it's clear to Hamza? What about Maeve? Okay, it's clear to Maeve also. That's good, right? So these are important techniques, right? I have also shown you how to be derived. ठीक है. So we have learned the introduction. Okay, what is momentum? We have learned how do we define it formally in words. We have learned how do we define it in basically using a formula, right? So I'm gonna give you a hint, a trick, right? Let's say if you forget the definition, just remember, just basically recall the formula, right? The formula is this. So if you, let's say, forget the definition of a quantity, just recall its formula and just write down the formula in terms of word, right? So it is pretty simple, right? It's mass times velocity, right? If you let's say forget the exact terms of a definition, you can just ex- write down the formula in words. Okay, that will give you 1 mark. Okay, so then we have conservation of momentum, right? Like we are living in universe, right? We are living in solar system. That is, we are living in Milky Way galaxy, and inside the Milky Way galaxy, we have a solar system, right? So if you recall anything, right? Atom, from atoms to universe, right? Everything is conserved, right? So in physics, we always maintain conservation, right? Whether it is conservation of charge, conservation of momentum, conservation of mass, okay? So we always want every quantity in the universe to be conserved, right? Up, keeping that in mind, can you explain, give me an idea, what is conservation momentum? A rough estimate, a rough idea. I just want to have your point of view, right? Whatever you understand till now. Raise your hand and just share your views. I want you guys to participate, please. That's how I can realize कि how should I plan my lecture, right?
सर अगर दो बॉडीज कोलाइड होंगी तो
Yes.
इन पे उनका जो मोमेंटम है टोटल मोमेंटम सेम होगा कांस्टेंट होगा
Mhm.
और कोई एक्सटर्नल फोर्स नहीं होगी स्टोन के ऊपर
Okay, good. Anyone else? What about Ryan? What are your views for conservation of momentum? Yes, Ryan. Ryan, give me a guess. Is Ryan here or is Ryan having a cup of coffee or chai and just enjoying the class?
Sir, I'm here.
Just give me a hint or just guess what is conservation of momentum.
Sir, when two bodies act on each other
Mm-hmm.
or in any way,
Yeah.
uh, the total momentum remains constant. It stays the same
Okay.
if no external forces act on them.
Okay. So, do you agree with this statement? Should it stay conserved or no?
It should.
It should, right? Well, likha वैसे is written over here. It should, right? We are studying this chapter. Okay, it should, right? Let me just give you an example, right? Okay. Let's imagine we have a very reckless driver, right? We have a reckless driver. This is your road, and this is your, let's say, a wall, right? This is your wall. Let me just draw two cars. That's more better. This is car A. We have two reckless drivers. This is, let's say, the Toyota of 1999, right? And this is, let's say, another Toyota, right? But I can draw only Toyotas. That's my skill, right? I can give you vintage vibes. Okay, so this is car A approaching over here, and this is car B. Okay, this is before collision, before they collided, right? What happened? And then let me draw case number two. Now we have a case number two. That is, ये क्या हो गया? There is a buffer, right? There is a case number two that is after collision, right? Okay, so now what happened? The two cars stuck to each other, right? They stuck to each other. Let me just draw if they are pretty broken. They are stuck to each side. This is again car A. This is car B. Right? So now let me give you some values, right? Let's say the mass of this car is the car A. The mass of car A is, let's say, 50 kg. Let's imagine 50 kg, right? Not 50 kg. It should be 500 kg. And the mass of car B is, again, it's the same model. It's 500 kg, right? And this velocity of the car A is moving at a velocity of, let's say, 10 meter per second, right? And this velocity of the car B is again 10 meter per second, right? Now, after collision, what happened? The masses are same, right? The masses are same again. That is 500 kg of mass car A, and the car B has also a mass of 500 kg. But they stuck and they basically stopped, right? The final velocity is basically 0 meter per second for car A also. And for car B, the final velocity is again 0 meter per second, right? So these are two cases which I want you to see. Okay. Now, acha, just recall your mathematics class, right? This is your positive x, right? And this is your negative x, right? So we're gonna take this direction as positive, okay? And we're gonna take this direction as negative, right? Because velocity is vector quantity, right? अच्छा मुझे बताएं कि इस velocity vector or scalar? Is velocity vector or
Vector.
scalar? Why?
It has a direction.
So it has basically magnitude. Let me just write the short form. It has also direction, right? So direction के लिए we are basically specifying our assumption, right? So this direction is going to be positive and this direction is going to be negative, right? So if you see this car is moving in this direction, right? So it has positive velocity, that is VA. This car is moving in left direction, that is going to have a negative velocity, that is going to be negative V, right? Now let's do some calculations, right? So let's try to understand what is conservation of momentum. What are we talking about, right? It's a collision, right? So car, they were moving before, and then after collision, they stuck to each other, right? They stopped. Okay, so now do let's right. Okay, so let me insert a blank slide again. Blank slide is okay. So let me just do some calculation, right? This is before collision. So what does conservation of collision? इसको मैं बाद में करते हैं, ठीक है? Let's find the momentum before collision, right? Let's find the momentum before collision, right? Before collision. ठीक है जी. So it's going to be basically sum of both of them, right? Because this body has, what is the momentum of car A before collision? That is going to be the mass of car A times the velocity of car A, right? And what is going to be momentum of car B? Because momentum formula क्या है? The momentum formula is mass times velocity, right? So we are just simply multiplying the individual masses and the individual velocities. What about the momentum of car B? That is going to be the mass of car B times the velocity of car B. ठीक है? So now I want to find the total momentum before collision. Okay. So for total momentum before collision, I'm going to add momentum A plus momentum B. Right. So that is going to give me the total momentum before collision. That is momentum of car A plus momentum of car B. Right. So what equation do I get? That is mass of A times velocity of A plus mass of car B times velocity of car B. So we are giving some values over here. That is mass of car A is 500 kg. The velocity of car A at this point is 10 meter per second, right? And we have also seen the direction of velocity is going to be positive. The VA is going to be positive 10 meter per second, right? Now, similarly, if you see this, the velocity of car V is moving in left direction. So it has a negative velocity, right? So therefore, you can include a sign of negative with this velocity, right? Because velocity is vector quantity. It will have direction, magnitude, and SI unit, right? So just put in the values. The mass A is basically 500. Mass A is 500 kg. The velocity of A is plus 10 meter per second. Again, the mass of B is 500 kg. The velocity of B is going to be basically is negative 10 meter per second. Right? You have all the values. Just substitute the values in the equation to get your answer, right? So it's going to be 500 times plus 10 plus 500 times negative 10, right? So what is your answer coming out to be? Momentum before collision. So BC stands for before collision. What is the answer coming out, guys? What is the answer of momentum before collision? What is 500 times 10? It's 5000. Okay. And what is 500 times negative 10? It's negative 5000, right? So it's coming out to be 0 Newton second, right? So the answer of momentum before collision is coming out to be the total momentum before collision coming out to be 0 Newton second. So according to now, I'm going to get back to conservation of momentum afterwards. Let's find the momentum after collision, right? So how will I find momentum of car A again? Is going to be mass of A times velocity of A, right? What about momentum of car B? Again, mass of car B times velocity of car B, right? And how will I find the total momentum after collision? I'm going to add these 2 points together, right? So now let me just do this. So let's talk about now before after collision, right? So what is the equation? Basically, I'm going to represent this at as AF. Okay? Sorry, AC. AC is after collision. Just to save my time. So momentum after collision is going to be momentum of car A after collision plus momentum of car B after collision, right? So this comes out to be what? Mass of A times V of A, final speed of car A time plus mass of car B times the final speed of car B. Okay, जी? So you know the masses and you know the velocity. So MA is 500 kg. The final velocity of car A is 0. So you don't care about the sign right now. The mass of B is again 500 kg and your final velocity of car B is again 0 meter per second. Right? Because they both stuck to each other, they both stop after collision. Right? Just put in the values to get your answer. So after collision is going to be what? 500 times 0 plus 500 times 0. So therefore, the after collision momentum is also coming out to be what? 0 Newton second. Right? Now let me just get to your conservation of momentum. Okay, what is conservation of momentum law? What is conservation of momentum? So it says the following, right? That is the sum of momentum before collision is equals to sum of momentum after collision. Right? So that is the law of conservation of momentum, right? This symbol means sum, right? This symbol means sum. It stands for sigma. इसका नाम है sigma. It's a Greek term again, right? So if I write this down in terms of words, that says the sum of momentum before collision is always equals to sum of momentum after collision, right? So what is the assumption over here? We're assuming that there is no friction, right? There are no losses, right? Over here. So we are assuming what? We are assuming that there is no friction, right? Okay. So we have no losses of momentum, right? So momentum is only transferring between the cars. Okay. It is not going to surrounding, right? There is no loss. Okay. So now let me check this same thing, right? So momentum of before collision, that is BC, should be equal to momentum after collision, right? So can anyone tell me what was the momentum before collision in our example, which we did it right now? It's 0, right? So 0 is coming out to be after collision is 0, right? So therefore, हमारा जो conservation law है, it passes and it says कि this is correct, right? That is, it is saying कि your momentum is conserved, right? The momentum is conserved. Okay. So I believe it is clear. I went pretty slowly and I tried to show all the steps in between, right? So if it is clear, if the example is clear, give me a raise of hand. Just give me a thumbs up. Yeah, if it is clear. It's clear to Mashal, it's clear to, it's not clear to Hamza, not clear to, it's clear to me, if good. Hamza को clear है, ठीक है? So that is your summary of conservation of momentum. I hope it makes sense, right? I try to include values so that it makes more sense, right? So this is summarized over here in this slide. Okay, conservation of momentum. So what does it say? Let me just try to skim it out. So when two or more bodies acts on one another or collide, right? The total momentum of the bodies remains constant, right? Provided there are no external forces, friction वगैरह नहीं है, कुछ losses नहीं हो रहे. So if a definition comes in your exam, what is principle of conservation of momentum? So you should write this down, right? That says that when two bodies collide with each other, right? Total momentum of the bodies remain constant, provided that there are no external forces, right? So that should give you the marks of your question. Okay, what is principle of conservation of momentum, right? I hope it makes sense. Now we have also done an example so that I can test you guys. So now everyone take out your copies and a pencil and a calculator and solve this question. So you have two basically masses over here. You have mass A, that is a trolley, and then you have another trolley, okay, a truck, okay. Let's say they are given a truck of mass 60, and you have basically a truck of mass 30, right? So this is mass A, let's say. Okay, guys, am I audible?
Yes. Yes.
Okay, good. So I guess let me wait for 1 more minute till everyone joins. Okay, Ji, so everyone is here. The rest can join in midway. So now what you have over here is that you have two trolleys over here. Of course, the masses भी दी हुई हैं. Let's say this is mass A, this is mass B. The basically the initial velocity of object A is 3 meters per second, and the initial speed is basically of B is 0, right? Because it is at rest. Now this is basically before collision, right? This is before collision. Now after collision, again the masses are same, right? This is mass A, this is mass B. What happens? This is after collision. The bodies stick together and they start to move in this direction together, right? Okay, you want to find this velocity v, right? So you want to use basically conservation of momentum law to find out the value of v, right? And what does it say? It says the following. Okay, it tells you the following thing, that is the sum of momentum before collision is equals to the sum of momentum after collision, right? Now I'm going to give you guys 10 minutes to complete this question. Okay, जी? And once you're done, you should raise your hands. Okay?
सर मोमेंटम का फॉर्मूला लिख दें.
Okay, याद नहीं है अभी तो इतना बताया आपको मैंने multiple times. Momentum is basically mass times velocity. Okay, जी? We have 10 minutes to complete this question, right? And then उसके बाद we have explosions. We will do it in next class. ठीक है? I don't want to rush. Complete this and you have now 9 minutes to complete this. Okay. If you're done, raise your hands. Okay, Hamza is done. You have basically 6 more minutes. Ryan, Mashal, and Maeve. Okay, so Mashal is also done. That's good. So we're gonna wait for let's say 2 more minutes for me. Okay, Ri. So let me just ask for your answers. What is Hamza's answer? Hamza, what do you got for the velocity?
3.
1 minute, okay. Let me just write it down. Okay, so Hamza got 3. Wait a minute. What about Ryan?
Sir, I also got
Okay, Ryan also got 3. What about Mashal?
Sir, I got 2.
Mashal got 2. Okay, I like the difference. Someone should be different, right? So now let's start the solution, right? Let me just start the solution, and you can then compare your answers. Okay, were you wrong? Were you correct? Okay. Okay. So let me insert a blank slide now, and let me duplicate this. Let me duplicate this. Let me snip this. Okay, we can solve it side by side, and we have this snap. Okay, Ji. So let's start the solution here, right? I'm going to solve step by step in detail so that everyone understands what is going on. So let's start with before collision, right? Let's start with before collision. ठीक है जी. So we have learned that this direction is positive, right? And this direction is negative. So let me write down the formula that momentum that is before collision is equals to should be equal to the sum of the truck A plus the momentum of truck B, right? And how do you find the momentum? You know the formula, right? That is going to be ma times initial speed of UA of truck A is plus the mass of truck B times the initial speed of drug B, right? So U represents initial speed, sorry, initial velocity, right? And V represent final velocity, right, of the drugs. So that you can understand the differences between the final or initial, right? Now let's put in the values. So momentum before collision is going to be mass A given to you, that is 60 kg, right? Going to be 60 times the velocity also given in this direction. So that is positive 3, right? Times positive 3 plus the mass of truck B is 60 kg. Sorry, the mass of truck B is 30 kg. That is going to be 30 and the velocity is 0 since it is at rest 0, right? So for this particular momentum before collision, the total momentum is coming out to be what? 60 times 3 is 180, right? It's 180 Newton second. Okay, Dee. Now let's work it out for after collision. Let me again duplicate this. So now we're talking about after collision. So now we have the same formula which we have seen for before collision. So momentum after collision is going to be again. Okay. Momentum after collision is going to be the sum of the momentum of car A. Now you see what is happening over here, right? This basically after collision combines together, right? They combine together like this. Okay. And they move with a fixed same velocity, that is v, right? So if I want to assume, right, if we see this over here, what is the scenario here, right? They're acting like one single mass, right? Which is moving in the right direction with the velocity v, right? Plus v meter per second, right? So I can assume that this particular scenario has a mass of what? Mass A plus mass B, right? Because they have stuck together and they're moving together in the right direction, right? So now I can just estimate this as an overall sum of MA and MB. Okay? So that is going to be as follows. Or I can write down the equation also. Okay? If it does not make sense, you can write down the equation also. It will come out to be same. Your momentum after collision is going to be basically what? MA times V, because this is also moving at velocity V, plus MB times velocity, that is V, right? If you take V common, this comes out to be what? MA plus MB times V, right? Which was, I was saying this over here, right? Because when they stick together, they're moving together as a single body, right? So I can assume that this combined mass is going to be the sum of mass A and mass B, right? So now let's put in the values. The momentum after collision is coming out to be what? 60 plus 30 times the V. Therefore, the momentum after collision is 90 V, right? Newton second. So now I would need the help of conservation of momentum to find the value of V, right? So now let's apply conservation of momentum. It states the following, that sum of momentum before collision is equals to sum of momentum after collision, right? So what is the sum of momentum before collision coming out to be? That is 180 Newton second, right? 180 Newton second. What is the basically momentum after collision coming out to be? That is 90 V, right? And where V is unknown, coming out to be 90 V. Therefore, if I want to find V, I give me V, make V subject. So 90 हम multiply हो रहा है वहाँ पे क्या हो जाएगा divide, right? So get 180 divided by 90. This 0 and 0 cancel out. Therefore, we get 2. So your final combined velocity of both the bodies are coming out to be 2 meter per second. And Mashal got it right. That is pretty good, right? So that's how you solve questions. Then you want to understand the scenario, what is happening, and how should you demonstrate this, right? How should you explain this? So now Mashal means there is, right? Mashal got it correct. Okay, Ji? So if it makes sense, give me a thumbs up. Okay, how will you solve it? Give me a thumbs up. It makes sense to Mashal. Makes sense to Hamza. Ryan. What about Maeve? Maeve, are you lost somewhere?
I didn't understand it.
You understand? You didn't understand what part?
Like the whole thing.
The whole thing, okay?
Right.
So what is happening over here is follows, right? So आपके पास you have two masses, right? You have two masses. We are naming it as mass A, right? We're naming it as mass A, and we're naming this second truck as mass B, right? So this we have two scenarios, right? We have one scenario that is before collision, and we have another scenario that is after collision, right? So now this is at rest, right? So UA आपको पता है it's 3 meter per second. It's already given to you. VB is at rest. Rest means के it has zero velocity, right? So it is zero velocity, right? What happens after collision? After collision, they basically combine together. This body basically causes the 30 kg to stick to itself, and they both move in this direction with the velocity v. So we had to find this velocity. Okay, what is v at which these two bodies are moving after collision, right? Does the question make sense now, Maeve? What is the question asking?
Yeah.
Okay. So now we are solving step by step, right? We are solving first before collision, right? So you know, if you want to find total momentum before collision, it's going to be the sum of initial momentum of truck A plus the initial momentum of truck B, right? And we have basically fixed our assumptions. Okay, if the velocity is on the right direction, it's going to be positive. If the velocity is leftwards, it's going to be negative, right? So just write the equation. You know, okay, what is momentum? Momentum is simply mass times velocity, right? We are just giving subscripts to basically make it more simpler, to make it more understanding. Okay, what are we talking about, right? This is the momentum of A, that is mass of A times initial velocity of A, UA, plus mass of truck B times initial velocity of UB, that is truck B, right? So you know the values, mass A is 60 and the velocity of initial velocity of truck B is 3, right? Since it is right in the right direction, we're taking plus 3, right? Because right direction is positive, right? Then plus mass if truck B is 30, but it is at rest. So the velocity of truck B initially was 0. So we are multiplying with 0, right? So if you solve this, you get 180 Newton second. Is it clear till now? Okay. Now, after collision, what is happening, right? This truck is basically combining with the 30 kg and it's causing both of them to move at a velocity that is v, right? So we are going to basically create a collision after collision, right? So this is pretty simple. It's same as the before collision. That it says if you want to find the total momentum after collision, it's going to be the sum of final momentum of truck A plus the final momentum of truck B. Okay? So we just gave terms with subscripts. So mass A times V because it is moving with velocity of V. Right? If I just make some assumption over here. So the velocity for both the trucks after collision is V. Right? So हमने दोनों पे basically V place करा है. So I was telling you in this part कि if you just directly do it, understand it कि this truck A and this is truck B, right? So it basically combines together and causes both of them to move at a velocity v. So I can assume this to be a combined mass, which is mass A plus mass B, which is moving to the right with a velocity of plus v, right? So, or if you're confused about this, you can just directly use equations, right? From equation we have got till here, you can take v subject and it comes out to be same, right? That is mass A plus mass B. That I was saying you can take it as m, right? So this is basically m, the combined mass times v, right? You just put in the values. The mass A is 60, the mass of truck B is 30. So you get the equation to be as follows. Okay, your momentum after collision is 90 v, where v is unknown, right? You want to find v. Okay, D. Is it clear till now? Maybe this equation. Okay, it's clear to me. Okay. Now, finally, we are applying the conservation of momentum law. Okay. Let me save it first. So what does it say? It says the sum of momentum before collision should always be equal to sum after collision, right? So we're going to just equate the two momentum, right? We're going to equate before collision with the momentum after collision, right? So 180 equals to 90 V. From this, we can just make V subject and find V that is coming out to be 2 meter per second, right? So the combined two bodies are now basically moving with a velocity of 2 meter per second, right? Making sure that my momentum is conserved. Is it clear now? So explosions, right? So let me just quickly read this content and then we will start with the example. right? So momentum, like velocity, is a vector quantity since it has both magnitude and direction, right? So just I told you guys in the first chapter, right? The momentum is equals to mb. Yes, Ruba.
Sir, I won't be able to give the test on Friday because I'm having my monthly assessments.
Okay. ठीक है चल we'll see it out, figure it out, ठीक है? Okay. Don't worry about that. So momentum is equals to basically mass into velocity, right? So what, since we came to the conclusion that in a formula, okay, so what do you have? You have mass, which is scalar, right? And then you have v, which is velocity. Okay, so if any of the quantity in your formula is, sorry, velocity, hold on, it's vector. The velocity is basically v, and it is a vector quantity. If any quantity in your formula is vector, therefore the quantity of which we are finding the formula also is becomes basically a vector quantity over here, right? So momentum also has basically two things. It has magnitude and it has direction, right? This is pretty important. Okay. So vectors cannot be added by ordinary addition. So we would have to use basically uh make sure okay they are in the same direction, right? We have done this. How do we add forces? If we have a, let's say, a point mass, let's say if we have force in this direction, okay, F1, and if we have F2 in this direction, how do we find the resultant force? We have done this before, right? So similarly, I'm going to talk about some momentum. How do we basically simplify it out? If they act in exactly opposite directions, such as east and west, okay, like this over here, if we can see the example. So F1 is on the east and F2 is acting towards west. The smaller subtracts from the bigger, okay, and they can, or if they are same, they cancel out, right? The momentum is conserved in explosions, such as when it occurs in a rifle, right? So let me just give you an example. Let me just give you an example. Okay, what is happening over here? I want to see this. Okay. Okay. So now if I add a blank slide over here, so you might have seen fireworks, right? So what happens in a firework, right? Let's say this is the rocket over here, right? This is the rocket. Okay, जी. Initially it has basically it has chemical stored, right? It has chemical stored inside it. It has chemical stored inside the rocket, right? Okay, जी. So if I want to find the momentum of the chemicals before explosion, okay, जी. Before explosion is going to be basically the mass of chemicals times the velocity of chemicals, right? The initial velocity of chemicals, right? Let's say the mass of chemicals is mass of chemicals. मुझे value की I don't care about the value, but you can see that when the rocket is flying, are the chemicals moving inside the rocket? Let's imagine मैंने rocket को fire किया, right? The rocket is basically going up, but chemicals are stored inside the rocket, right? Until after a certain time, then they basically spread out, right? As fireworks. So initial velocity of the chemicals is basically zero, right? Because they are inside the rocket, they're not moving. Okay, when the rocket is initiated, right? So the initial momentum of the chemicals inside the rocket is 0 meters per second, right? So now here comes the question: K, before explosion, the momentum before collision is basically before explosion, right? Before the rocket's firework starts is zero. But how does, when it goes to a certain height, like the fireworks start, right? What How is the energy being transferred to chemical, right? Because we want to make sure the momentum after explosion should also be zero, right? So there should be some mechanics, some basically principles, depending upon which my momentum after explosion is also coming out to be zero, right? So let's see it out. Okay. Now basically this is before explosion, right? Now let's see after explosion what happens. So imagine these are the chemicals. One chemical is going in this direction, the other chemical is going in this direction, right? And this is the rocket, which basically which was carrying chemical, right? And now chemicals are starting to spread apart. So this is basically one chemical goes here. Similarly, the another chemical of same mass goes over there, right? Similarly, it goes over here, it goes over here, right? So this is, let's say, mass 1, this is mass 2, this is mass 3. So similarly, we have mass 3 over here, we have mass 2 over here, we have mass 1 over here, right? So you can see that after explosion, same amount of chemicals basically disperse, spread out in opposite directions, right? So let's say M3, one part is going here, the other opposite part is going in opposite direction. The M2, one chemical part mass is going in this direction. The same mass is going in basically opposite direction, right? So imagine it has speed of, let's say, V2. It also has the speed of V2, right? So let me just talk about this, right? This was because it will be simpler to understand, because it seems like a chemicals are moving in x axis, right? That is this. Okay, either it is moving in positive x or negative x, right? So if you just find out the momentum after explosion, that is going to be as follows, right? After explosion, that is going to be as follows. That M2 V2, the V2 is going to be positive because this is on the right direction, and this velocity is going to be negative because it is going in this direction, right? Plus m2 into negative v2. Okay, so the momentum after collision is going to be 0 Newton second also, right? Because momentum is also vector quantity. So particles spread out uniformly in opposite direction, right? So this is one pair, this is another pair, right? And we have another four pair which is this, right? So particles are spreading in opposite directions with same velocities, okay, which makes sure here your final momentum after explosion is also coming out to be 0 Newton per second, right? So if this part makes sense, give me a raise of hand. This just an application, right? Just an application of conservation of momentum in explosions. Does this part make sense? If yes, give me a thumbs up. Okay, it makes sense to Hamza. What about Mashal and Ruba?
Sir, can you explain it again for me?
Okay, so I'm
The
just
after collision part.
okay. So I'm just saying, is this part clear? This equation.
No, sir, not quite.
Okay, so just imagine that I'm talking about this side, okay, this part of chemical spreading, right? So यहाँ पे हो क्या रहा है? यहाँ पे some particles, some mass is going in this direction, and some mass of chemicals are going in this direction, right? So it has a V2 over here. It has the same speed, and the mass which is basically spreading around of chemicals are also same, right? M2 M2. So imagine if you want to apply the formula of sum of momentum after collision. So that is going to be as follows, right? So what is the formula of momentum? Momentum formula is mass is equals to what? Momentum is equals to mass times velocity, right? I'm just doing that over here, right? So M2 for this particular part, and this direction is positive, so the velocity is positive v2, right? Plus this this part of the explosion, that is M2 times the velocity is negative because it is going in the left direction, right? Times negative v2, right? So if you add them up, they becomes what? This is M2 v2 minus M2 v2, right? So what is M2 v2 minus M2 v2? Mashal? It's going to be
Zero.
0, right? So similarly, this is happening in this direction for the orange pair. Similarly, for green pair, it is also happening here. Okay. In every direction, the net, if you sum all of them together, you're going to get a sum of 0 Newton second after explosion, right? Does that make sense now? Okay. So this is how rockets are designed. And you would be thinking, right? Initially, अगर momentum 0 है, so how are they exploding? Okay. So they are basically exploding in such a way that if you sum all of their momentum, since momentum is a vector, so some side would be positive, some side would be negative. Okay. So if you add it up, you get a net value of 0. Okay. So this is now, let's do an example of rifle, right? So rifle, what is a rifle? I believe everyone does play PUBG or any games which basically include guns, right? So this is a bullet over here, right? So this bullet has a mass of 0.01 kg, right? And it goes in this direction, right? With a velocity of 300 meters per second, right? So now let me just go back to the content over here. So before firing, the momentum was, so before firing, the total momentum is zero, since both rifle and bullet are at rest, right? तो बिकॉज बिफोर फायरिंग बुलेट भी अंदर है, बेसिकली राइफल के अंदर है, और राइफल भी मूव नहीं कर रही है, सो द वेलोसिटी ऑफ बोथ ऑफ देम आर जीरो, सो देयरफॉर द मोमेंटम इज जीरो बिफोर firing, right? During the firing, the rifle and bullet receive equal but opposite amounts of momentum, so that the total momentum of the rifle is also zero. ठीक है? So similarly, let me just draw a diagram. Imagine this is your rifle. ठीक है? And this is your, let's say this, and you are basically firing it, right? So when it is being fired, so obviously it has some certain mass of gun, and this has some mass of the bullet, that is 0.01 kg, right? And this is basically moving with a speed of 300 meters per second. The bullet, right? And it is going in this direction, right? So if you have noticed some educational videos about how to fire a gun, you would see the bullet, there's a jerk on the hand of the firer, of the fireman, right? So the rifle basically will have a force, a certain momentum in this direction also, right? Okay, that is going to be negative V gun, right? So let's find the momentum of the gun after firing, right? So let's find the momentum of the bullet after firing it. So after firing, what is happening over here? So the momentum of the bullet is going to be as follows. That is mass of bullet times the velocity of bullet, right? So the momentum of bullet is going to be equals to what? That is 0.01 times 300, right? So what is the momentum bullet coming out to be? It's going to be 30, right? Sorry, 1 upon 100 is going to be 3 Newton second, right? So this is the moment of the bullet after the basically the firing over here. Okay, so what happens over here is as follows. So what is happening over here now? Can you explain if you use the principle of conservation of momentum, right? So the momentum which is transferred to the gun, right, that is momentum of B, is also transferred equally back to the gun also. Okay, that is going to be momentum of gun, right? So using principle of conservation of momentum, since before collision, before firing, right? So before firing, the total momentum was 0 Newton second of the gun. This is a combined momentum basically of the gun and the bullet, right? ठीक है जी? Let's say before firing, this was the case over here, right? So this is your gun. ठीक है जी? And the bullet is also here, right? Inside the gun. So they both are at a velocity of 0, right? If you apply the formula of momentum before firing, that is going to be what, right? Mass of bullet times velocity of bullet plus mass of gun times velocity of gun, right? Both velocity of bullet and gun are 0. Therefore, the momentum before firing comes out to be 0, right? ठीक है जी? Now, to basically make sure that your principle of conservation of momentum is correct, that says कि momentum of before firing should be some should be equals to sum of momentum after firing, right? So the left side is 0. So you want to make sure that the right side should also come out to be 0, right? So for that, I want this to be same, right? Because since it is going to be positive, it's going to be negative, right? If you want to find the total momentum after firing, that is going to be plus momentum of the bullet minus momentum of the gun, right? If they both are same, this is going to come out to be basically what? 0 Newton second, right? And this will basically make sure that my principle conservation of momentum is applicable, right? ठीक है जी? So using this assumptions and principles, the momentum of gun should also be basically be 3 Newton second, but it would be in opposite direction, right? Make sense? If it makes sense, give me a thumbs up. Makes sense to Mashal. Okay, good. Makes sense to Ruba. Okay, thumbs up also. Acha ji. So now let me just give you an example. Let's say the mass of the gun is, let's say, 0.8 kg. ठीक है जी. So let's find the velocity of the gun after firing it. So we know that the momentum of gun should be 3 Newton second, right? So now we are also given the mass of gun is 0.8 kg, right? It's 800 grams. Okay. So let's find the velocity with which the gun would move in this direction, right? The velocity of gun, right? Okay. So this since momentum of gun is equals to mass of gun times velocity of gun. This is 3 equals to 0.8 times velocity of gun. So what is the value of velocity of gun coming out to be? 3 upon 0.8. It's 30 upon 8. What is the answer in decimal points? It should be meter per second. 3 upon 0.8 is what?
3.75 meter per second.
Yeah, that's good. It's 3.75 meter per second, right? So what would happen? So let's say if you're holding the gun with your hand, okay? So you would also basically have to apply a certain force to overcome this, right? Because that's why you have a jerk when you fire, right? Okay? Because the rifle is trying to move towards you with a velocity of 3.75 meter per second, right? So yeah. So rockets and jets. Can you explain this? Can you explain how do we basically left the rocket into the air and make it leave the sky? So you can see here there is some fuel over here which is basically going in this direction. Okay, this is the velocity of fuel, right? And this is the velocity of the rocket which is going in this direction, right? And let's say rocket has some mass which is, let's say, mass of rocket, and the fuel which is coming out is also certain mass, that is mass of fuel. Can you explain me using conservation of momentum that how this phenomena is making the rocket to be lifted from the earth and accelerate toward the sky? It's pretty simple, right? If you want, I want any one of you to answer. Otherwise, I will call someone out. Yes, just give me a guess or your ideas. We have just discussed this idea using the principle of momentum in rifles.
सर
Yes,
एक दफा क्वेश्चन वापस पूछिएगा बताएगा
I'm just saying कि रॉकेट जब बेसिकली लिफ्ट हो रहा होता है, ठीक है, सो यू नो कि हमारे पास एक कुछ वेलोसिटी है फ्यूल की जिससे फ्यूल रिलीज हो रहा है एंड कुछ वेलोसिटी है रॉकेट की जिससे वो ऊपर जा रहा है, इट्स बेसिकली एक्सेलरेटिंग इट. So how is principle conservation of momentum is applied over here in this example, which is causing it to accelerate?
सर इसमें जो फ्यूल की जो वेलोसिटी है और वो मोमेंटम जो है जो रिलीज हो रहा है वो एग्जैक्टली सेम होता है उससे
Good.
जो रॉकेट जिस फोर्स
Alright.
से ऊपर जा
Perfect. So what is basically the output of this? इसका बेनिफिट क्या है फिर? लेट्स से हम उसको फ्यूल रिलीज कर रहे
रॉकेट स्ट्रेट लाइन में जाता है एक
हैं. ओके, परफेक्ट, परफेक्ट, गुड. ठीक है जी, that's good, right? So just imagine the beauty of moment, right? So we are applying this in creating rockets, ठीक है? So what this is basically, let's say initially what was the scenario? The rocket was stationary, right? Let me draw a good rocket. ठीक है जी. The rocket was stationary, ठीक है? It was standing, ठीक है? And this was fuel, everything was stationary, right? So let me just find the momentum before launch, right? So the momentum before launch, right? BL. So BL stands for before launch. Okay, जी. So what would be the formula for this? ठीक है? It has some certain fuels also. ठीक है? Fuels are here. ठीक है? Let me draw some using some highlighted. So these are fuel tanks, right, which is going to be releasing fuel, right? So it has some mass of fuel, right? And it has a mass of rocket over here, and initial speed of fuel and initial speed of rocket, right? So since it is at rest, nothing is moving. So the initial speed of fuel is equals to initial speed of rocket, that is zero, right? They both are at rest. So therefore, if you apply the formula, that is the momentum before the launch is equals to basically the mass of fuel times the initial speed of fuel plus the mass of rocket times the initial speed of rocket, right? So if you apply this, see the values and this, what would happen? The momentum before launch is going to be mass of fuel times zero plus mass of rocket times zero. Therefore, the momentum before launch of the rocket is 0 Newton second, right? Now, using principal conservation momentum, it says here the momentum before launch should always be equals to momentum after launch, right? That is, it should be 0 equals to 0, right? Now you want to make sure that this condition is getting satisfied, right? Now, this case is basically after launch, right? The rocket is accelerating. Okay. So the fuel is basically moving with the same speed as the rocket is accelerating upwards, right? So if this is positive and this is negative, right? Direction, since velocity is a vector quantity, it would have positive and negative direction, right? So if I talk about y-axis, this is positive y and this is negative y, right? So the up direction is positive and the downward direction is going to be negative, right? So now let's apply the equation after launch, right? Let's see what happens after launch. Okay, so let me now insert a blank slide over here. Okay, so now if you apply the equation of momentum after launch, that is going to be as follows, right? That momentum after launch is going to be what? It's going to be mass of fuel times the final speed of fuel plus the mass of rocket times the velocity of rocket. Okay. Since you can see the direction of final velocity is downwards, sorry, the fuel is downwards, it's negative. You can put a negative sign here, right? And the rocket, the velocity of the rocket is positive. Okay, so it is positive. Okay, since it is moving with basically zero acceleration, that means the vr is equals to vf. Okay, so these both quantities are same, let me call it as v. Okay, दोनों की speed की magnitude same है. ठीक है, v can be 10, 15, 35 meter per second, whatever the value is, right? So since the both are same, okay, so you can just substitute the values. That is going to be mass of fuel times the negative v. Okay, so negative v plus mass of rocket times v, right? अच्छा जी, अब mass of this is the rocket is designed in such a way that the mass of rocket is always same as mass of fuel also. ठीक है? So since they both are same, they cancel out, and this will basically give us again what? The mass, the total momentum after launch is also coming out to be 0 Newton second, right? So जितना basically mass of fuel save किया है in the rocket, उतना ही basically mass of fuel होता है, so that they cancel out each other and you get a final momentum of 0 Newton second. That basically makes sure that your sum of your principle of conservation momentum is getting applied, right? Is it clear? If it is clear, give me a thumbs up. Just an example to make you basically realize how our rockets launched, right? How is momentum used over here? If it makes sense, give me a thumbs up. It makes sense to Ruba. What about Hamza and Mashal? Yes, are you here? Okay, makes sense to Hamza. Mashal, are you here? Okay, ठीक है. So now it's just, let me just quickly skim through it. Okay, what are they saying? So if you release an inflated balloon, okay, with this neck open, okay, it flies off in opposite direction, right? You might have seen the experiment. आपने balloon को expand किया, and if you release it open, so basically the air is going in this direction. It causes the balloon to accelerate in this direction, right? So this is again an idea of application of momentum, right? So in figure 1.6.3, A has momentum to the left, the balloon has will basically moves to the right with equal momentum, right? Okay, to basically make sure that the sum of momentum is always same, right? This is the principle of rockets and jet engines. In both, the high velocity stream hot gas is produced by burning hot fuel, and it leaves the exhaust with large momentum to basically make sure that the rockets accelerate upward, right? So again, it basically gives the rocket an equal forward momentum, which causes the rockets to accelerate upward, right? Which we have seen in the example, right? So now some more application. Now I'm gonna derive some relation between force and momentum, right? So the meeting is about to end. Kindly rejoin. I'm gonna just finish it out, and yeah, we'll take 15 more minutes. Okay. Kindly rejoin the time. So yeah, force and momentum. Okay. So the relation between force and momentum is basically as follows, right? That force is the rate of change of momentum, right? So if you recall the Newton's second law, can anyone tell me Newton's second law? What Newton's second law?
F equals to ma.
The definition. What about the definition in terms of word?
Yes, the second law of Newton's second law of motion describes as if you apply a force on a block of mass, an acceleration would result as a product with the direction of that force.
Okay, good, right? So now I want you to focus on those words, and this is summarized basically as follows, right? F is equals to ma, right? So now I'm gonna pay quick attention. I'm gonna derive this, right? Okay, how do we go from here till here, right? So this is basically another representation of Newton's second law. Okay, so this is another representation, another form of Newton's second law. So let's say if you write this down, this definition in your Newton's second law, it will also be accepted, right? There's another, I can say, version of Newton's second law. Okay, so it states K, what is basically force? It states K, force is the rate of change of momentum. Okay, ji? This definition is pretty important over here, right? That force is the rate of change of momentum, right? Rate of means K, any quantity which comes after rate is going to be basically divided by time, right? That makes sense. But rate of what? Change of momentum, right? You can see delta P. Okay, ji? So this states K, force is equals to delta rho divided by delta T, right? Delta means change, right? And rho is momentum and T is time. So force is basically the rate of change of momentum, right? Okay, Ji. So impulse. Then we have impulse over here. So can anyone define K? What is impulse? Yes, give me an example of impulse.
Sir, impulse is when a resultant force acts on a mass. The momentum of that mass will change.
Yes, good. ठीक है, perfect, right? So this is again, this definition is same जो मैंने आपको बताया कि resultant force is the rate of change of momentum. Impulse is what, right? Imagine this. Let me just give you a real life example. That is, imagine that there's a driver who is driving the car, right? And this is, let's say, a Rolls Royce, okay? And the person is driving the car and he's sitting here on the wheel, okay? So now basically suddenly, let's say he crash into a wall, right? He crash into a wall, okay? So what happens? His head basically hits the wheel, right? The contrast between the head and the wheel, right? Let me just draw the head. Let's say this is the head of a person. The contact is basically for such a small time, okay? That is delta t. So that is going to be, let's say, 0.0001 second. ठीक है जी. And if you recall the formula of force, that is change in momentum, rate of change in momentum. ठीक है जी. So if this part is pretty small, if this is really really small, ठीक है, let's say this is 0.0000001 second. So this impact in such a short duration is called an impulse, right? And this can create serious injuries, right? So imagine, let's say, if a person fell down off his bicycle, right? And you can see his head, his or her head starts to bleed, right? So what happens when they fell? They basically they contact with the ground for such a few short of time, such that it impacts in such a huge way that it cracks either of the parts of the bone, right? So this impulse is very, can say, threatening in driving, right? So whenever a car is designed or a bike is designed or a helmet is designed, so they always check their impulse response, right? How would the helmet, how would the car, how would the bike, okay, or how would the car is designed to basically absorb the impulse, right? So they want to minimize this, right? They want to minimize these cases to avoid such serious injuries, right? Does impulse make sense? If yes, give me a thumbs up. And what is the second representation of force? I derive the formula now. Why it will make sense? ठीक है, कैसे formula है ये? Okay, good. Now let's derive, right? So let's derive this formula, that how it came into picture, right? So we have this formula which we have studied in your forces, that is Newton's second law, that F is equals to ma, right? We want to go from here to this new shape, that is F is equals to change in momentum upon change in time, right? How do we go from here till here, right? Okay, so before this, I'm gonna take some help from some equation which we have also studied before. So we define acceleration as follow, right? It is the change in rate or change of velocity rate, v minus u divided by t, right? Where u is what? U is your initial speed, right? Or initial, you can say velocity, not speed, initial velocity. Sorry, it is your initial velocity. Okay, G. So yeah, if you have any question in the derivation, just stop me there, right? At whatever step you get lost. Okay, my PowerPoint is just breathing its last. Okay, let me just rub this. So this is initial velocity. Okay, U means initial velocity and V is your final velocity. Make sure कि आपको आता हो, this derivation comes in your exam, right? And then T इसको बोल देते हैं हम, delta T बोल देते हैं, right? So delta T is your change in time, right? Delta T is your change in time. ठीक है जी, now let me put this form into this, ठीक है, into this equation, right? So what happens? This comes out to be F equals to m times V minus U divided by delta T, right? So if I expand this, it comes out to be as follows: that force is equals to mv minus mu divided by delta T, right? आप मुझे कोई बताएगा what is mv, what is mu? Yes, so we are at this position right now, that F is equals to mv minus mu divided by delta T, right? So if you just imagine, okay, there is a wall over here, right? There is a wall over here, and let's say the car is moving, right? ठीक है जी, it has certain initial velocity, that is u, and it has a mass of m, right? Let's say it hits the wall and it has some certain final velocity, and the mass is going to be same, right? So now using, चलिए इसको हटा देते हैं. Let me just give you a simple example ताकि it will make more sense to you guys. Let me just give you example of a tennis ball, right? This is your, let's say, a wall, and you are standing over here. You're trying to play with the ball, right? You throw a tennis ball. You throw a tennis ball in this direction, right? So it has a mass m, right? And it has initial speed of u over here, right? So after bouncing back, it goes in this direction towards you. Okay, it has a final speed of negative v now, right? Okay, so if I want to find the initial momentum of the ball, that is going to be what? The initial momentum is going to be mass
Final momentum
times
minus.
initial speed, right? Yeah. If I want to find the final momentum, that is going to be the mass times the final speed, that is going to be negative v, right? So it comes out to be negative mv. So if I want to find the change in momentum, okay, that is going to be what? Final momentum minus initial momentum minus final momentum, right? I want to find the change. It's going to be basically initial momentum plus final momentum, right? So that is going to be mv. Okay, एक मिनट, okay, I just made a sign mistake over here. Okay, जी, v minus u t, ठीक है जी. Yes, change is going to be this. Let me just take it this over here. This is going to be as follows, right? This is changing momentum over here. That is final initial momentum minus final momentum. Okay, sorry. Let me just fix it out over here. So the change in momentum is going to be as follows. The final momentum after minus initial momentum, right? Okay. So this is going to be your delta P, right? So what do you see over here? The final momentum, right? And what do you see over here? The initial momentum, right? So this quantity is basically delta P, that is mv minus mu, right? Therefore, your force is coming out to be what? It is the change in momentum divided by the change in time, right? So this is another representation of finding your resultant force, that is rate of change of momentum divided by time. Make sense? Good. So basically over here, what is happening? Let me just draw the diagrams that you can relate. Okay, so if I want to find the momentum before the strike, okay, so that is going to be, or simply momentum before the collision of the ball in the bat, okay, that is momentum before. It's going to be simply equals to what? M1 U1 plus M2 U2, right? And if I want to find momentum after the strike, that is going to be equals to what? The mass of the ball M1 times the final velocity of the ball plus the mass of the bat plus final velocity of the bat, right? So this is basically your momentum application getting applied over here, right? So if I assume, but I should not assume, basically from conservation of law of momentum, we have the following relation, right? That the sum of momentum before collision should be equals to sum of momentum after collision, right? So that is how it is getting applicable over here, right? So this is all momentum in action, right? In physical world. So whatever you have learned, and this is getting applied over here, right? Okay. So this is basically the application of momentum in cricket. So let me just take you back to the theory, that is this. Let me save it. Okay. So okay. Is my screen visible? The last slide. Has the slide changed?
No, sir.
Okay. Let me reshare the screen. Okay, is it visible now? Is my slide seen? Are my slides seen?
Yes.
Okay. So now simply they're stating over here how is basically impulse getting applied over here. So cricketer we have seen over here. So now the force applied then acts for a long time, the impulse is greater, so also is the gain of momentum over here, velocity of the ball, right? They're saying how does basically momentum is getting applied onto the ball from the bat, right, after collision. So the velocity direction changes, okay, but still the conservation of momentum law says the total momentum before collision of the ball in the bat should remain same constant after the shot, right? After the strike over here. So when we want to stop a moving ball, such as a cricket ball, however, its momentum has to be reduced to zero, right? So an impulse is then required in the form of opposing force acting for a certain time, right? So imagine, have you tried catching a tennis ball or some, let's say, some cricket ball? Let's say if you are trying to catch a ball, so do you feel some, let's say, some sharp sort of an force on your hand when you catch it? So who has played cricket till now with your cousins, friends?
क्रिकेट नहीं वो सर बास्केटबॉल खेलते हैं ना तो जब पास करते हैं बॉल तो उस वक्त भी होता है
Okay, so any sport in which you basically have to catch a ball, I believe any everyone of you had played some sports which includes catching, let's say,
Yes.
basketball or cricket ball. If yes, raise your hand. Hamza has played cricket. Ruba also did. Varda also did. Mashal also did. What about Maeve? Maeve, you haven't played any sports?
Not really.
Okay. ठीक है. So Hamza, जल्दी से explain करें what happens when you try to catch a ball to Maeve. Yes, Hamza. Hamza, are you here?
और आवाज आ रही
Yes, I can hear you now. Explain the scenario of catching a ball to Maeve.
सर जब होता है तो बॉल का मोमेंटम हमारे हाथों से ज्यादा होता है इस
Yes.
पे आपको थोड़ा अफेक्ट फोर्स पड़ती है
Yes.
ऑपोजिट डायरेक्शन जिस डायरेक्शन में बॉल जा रही है उस डायरेक्शन में फोर्स पड़ती है
Yep. So this is basically you want to basically stop it, right? So your hand would apply a force, sort of a velocity in this direction, right? Instant velocity of your hands, right? And these are the masses of hands. So you want to basically make the velocity to be zero, right? Okay. So what happens as soon as the ball basically comes in your hand, okay? So you apply this formula, right? So your force is rate of change of momentum, right? So you basically catch the ball in very small time, right? Let's say in 0.001 seconds, right? And let's say the change in momentum will be what? It would be m of b minus basically vb minus 0, right? So this is basically an application over here. You can see it is divided by 0.001. So this means your force would be mb times vb times 1000, right? Because what is 1 upon 0.001? It is equivalent to 1000, right? If you reciprocate and use your calculator, you will get this value. So this means your force would be 1000 times the mass of ball times its velocity with which it is traveling, right? So it's going to be a huge force which your hand tries to basically overcome. And this phenomena is basically called impulse, right? If you try to basically stop a ball, let's say an object which is traveling at a speed, let's say VB. So, and it is, let's say you make the contact with the ball, you stop the ball in a time of 0.001 seconds. So your hand would basically face a force of 1000 times mass of ball times velocity of B. Let's say the velocity of B is 10, right? And the mass of the ball is, let's say 0.5 kg, right? So let's find out the value of the force that the hand has to basically stop, right? So it's going to be 1000 times 0.5 times 10, right? So what is the answer which you're getting? It is 5000 newtons, right? So that's a huge value. So this particular phenomenon is called impulse, right? So if impulse is basically the rate of change of momentum in a short duration of time, right? So that is your impulse. If it makes sense, give me a thumbs up. If it makes sense, okay, what is impulse? And this example makes sense. Give me a thumbs up. It makes sense to Varda, Ruba, Maeve. What about Hamza and Mashal?
So
Makes sense.
can you explain it again?
Which part?
The impulse part. That
So what is impulse? Can you explain impulse? Yes. So it's basically a force applied in a very short duration of time. Does that make sense? You can see the time is 0.001 seconds. It's pretty small, right? So in this particular duration, you're applying basically your hand is applying a opposing force of 5,000 Newton. Basically stop the ball, right? Okay. So what they will do, we basically find out the change in momentum of the ball, right? So what is change in momentum? It's basically the initial momentum minus the final momentum, right? Right. So initial momentum is basically what the mass of b times the velocity at which it was traveling before it was caught. Okay, and the final velocity of the ball is basically zero, right? So we can just use this formula. That is m. Mass remains same for both the cases, right? So your changing momentum of the ball is m of ball times initial speed of ball minus m of ball minus final velocity of ball, right? So initial velocity of the ball is I can take mb as common, right? Because they are both common in this particular equation, right? I can take this common over here. It's getting multiplied by the way. So this becomes initial speed minus final speed, right? So your momentum of your changing momentum of the ball is simply VB minus zero. Since final speed of the ball is zero, since it is basically stopped, right? Stopped by the hands of a catcher, right? So this is basically coming out to be this. We have fixed time to be, let's say, 0.001 seconds for an example. So 1 upon 0.001 is 1000, right? If you use a calculator, you get your answer, right? So if we just use some example values, let's say the mass of the ball, clear ball is 0.5 kg, and the velocity at which it is traveling is 10 meter per second, right? So what would happen? You would basically, it is providing a force, a value of 5,000 Newton. That means your hand is basically applying a opposing force of 5,000 Newton just to stop this cricket ball. Okay, so that is a huge value. Okay, so that is called an impulse. Make sense? Okay, good. Yes, Hamza? Okay, I believe it is clear to everyone. So this is just an application, right? So don't just find chem physics is boring, such equations पढ़े जा रहे हैं. So it is getting applied to everything, right? Whatever scenario you can think of, your concept are getting applied over there, right? Yes. So now we have the last case, which is basically explaining how is momentum basically getting control in this sport. So you might have seen this sport is called long jump, right? So it's sort of a long jump sports over here. The runner basically comes running and he jumps on the soft sand to basically cover a sort of a distance of the. Okay, let's say this is your sand. The jumper comes running, okay, and he jumps, right? And he jumps. He basically tries to land at a particular point, and this is your basically the length of your jump, right? And the greater it is, and basically that means you have won, right? But over here they use soft sand, right? They use soft sand. Can you explain the importance of using soft sand? How is it helpful in the landing of this particular, let's say, jumper? How is it helpful? Raise your hand, answer. It's pretty simple. Yes, Rupa.
Sir, so when they will use soft sand, so it will have less friction between the person and the ground. That's
Good,
why.
good, good.
So the
Yes,
person who is playing a sport will be able to travel along a greater distance as compared to any other thing that would be used on the ground.
perfect. Anyone else? Good, Rupa. You almost got it there, right? So that is the exact reason which was basically required and it is written over here. So while any number of combinations of force and time will give you a particular impulse, the sting can be removed basically from the catch by drawing the hands away. This is basically saying here. Similarly, if you want to basically catch the ball softly, there is a technique in cricket, right? So you move your hands away, right? So you can watch the video of how do we catch a cricket ball, TK, which will explain, right? So similarly over here, they have used soft sand over here, which basically tries to reduce the impulse, right? So this basically reduces impulse. Okay. How? Because it reduces the force that is basically getting applied by the ground, right? So it reduces this force over here, which basically makes the landing to be soft, right? So the jumper cannot be basically injured in this particular sport if he's following a proper technique and the sand is soft, right? This is just simple application of momentum over here, and this basically ends of your chapter. So we have learned what is the relation of momentum with force. We have learned the rate of change in momentum, right? So we have defined momentum and its application, where is it used. We have basically derived the formula for impulse. Okay, that is this. And this basically takes us to the question answer, right?